Well, thanks, Renee, and it's my pleasure to actually attend here and showcase some of the research done by UTS, as partnering ATN. In this case, I'm from the field of robotics, and the project we're showcasing is actually in agribusiness. It's in improving productivity in the beef and sheep industries. MLA Meat and Livestock Australia is actually acting on behalf of the producers in dedicating funds and funding ourselves and New South Wales DPI and UNE in pushing forward this research. So the beef industry in general also has embraced on new consumer demands, and there's a push or paradigm shift to pay producers not based upon purely weight of animals, but on meat quality. And currently losses due to not meeting these demands from individual producers can be up $10 in sheep and up to $80 a head in cattle, which is a significant amount. And I think I've read, or was quoted somewhere in the order of $80 million over 4 years, the loss in not making up to market specification. So there's a way to address this, and it would require to estimate traits of animals during the production process on farm and integrate those measurements in on-farm management systems where you could alter the feed and therefore affect the end yield of animals. So it could be used in management in twofold. It could be used in breeding to actually determine whether the animals are suitable to actually sustain offspring and can be mated, or it could be, as I've noted, in looking at whether the animals have the capability of meeting market specifications and possibly altering their feed so that you would affect the final grading. Through the beef CRC, there was 20 years of research in looking at developing the fundamental tools on how yield is affected through the life cycle of an animal through its intake. And the Beef CRC embodied University of New England and various other universities in Australia. Those tools became readily available, and one of those is BeefSpecs. So given some genetic traits of the animal and given its current status, it can predict what the animal will be like given a certain amount of feed, be it pastures or grain-fed. And also it can estimate the results in 80 or 100 days. There's also some information flow that can be then achieved back to the producers, but capturing these traits in field remains something that was only undertaken by experienced assessors. So it's a skill that you will develop through years of being involved with animals. And given the shortage in staff in general in the agricultural industry, this was something that became even more harder to actually obtain, and therefore our skill sets in robotics on perception and analysis and artificial intelligence came into play. And we became involved in a cross-disciplinary project that has identified here in the forum. There's truly some leaps and bounds to be made in projects of cross-disciplinary nature where researchers from vastly different fields that might not overlap generally can meet and produce sufficient outcomes. So in here, Meat and Livestock Australia identified that this was a critical need and engaged us and New South Wales DPI, the Beef Centre of Excellence, who were part of the Beef CRC. So the task was mainly in the domain of robotics, where we were looking at ways of getting information of moving animals and then representing this mathematically so that it's akin to a human interpretation of an animal. So the expert assessors look at volume of an animal in certain areas, and they look at how that volume moves, which reflects muscling. And therefore the task was how to represent this mathematically and then incorporate some artificial intelligence into the system so it would reason. So given that it sees these volumes and changes in muscularity as the animal moves, what does this then relate to its underlying muscling and fat composition? Which then at the end could be used for predictive analytics to actually derive these measurements of animals while they're still in field. So just to show what this looks like in practice, so there's a system of connected cameras that capture an animal while it's still moving in a race. So there's sufficient enough 3D points, you would say, of an animal that you could complete a 3D representation of surfaces of the outside of the animal. And akin to what a expert assessor does, he will look at the distribution of these shapes as to where animals deposit fat and also where they actually have a lot of muscling visible. So we generate a complete 3D model of animals, and then from the models of the animals and all the shapes of animals and machine learning and artificial intelligence has ever seen, it can deduce some properties. In this case, it's a muscle score, which is an indication of how much muscling is on the animal when you combine it with live weight, and also a P8, which is reflects the amount of fat on an animal. So we're currently working with Meat and Livestock Australia in pushing forward this initial proof of concept study and looking at some other traits that could be estimated using 3D data and machine learning, such as structural soundness, and other traits that usually require an experienced operator to go around amongst the herd and observe it for a period of time. Well, in this case, if we can get the animals to walk through a race and actually expose it to camera systems, we'll be able to predict these traits. So this is one of the examples where a skill set might not necessarily have been in New South Wales DPI in machine learning, but we could bring our complementary skill sets to them and bring a project like this to fruition.